So, right. Well, good morning. Good morning, and thank you very much, especially to Tamanu and to Ergo for inviting me to be here with you this morning. Great. Thank you to the rector, who I understand has left, and thank you to Rhoda Elias for very important, I think, introduction, because I think, Rhoda, you have introduced us to the fact that building information modeling, or BIM, is a social exercise. It's not necessarily a technical exercise. And as a social exercise, it means that what it's really all about is collaboration and cooperation between people. We can get smart buildings only if we have smart people. And it's not the BIM technology that makes all the decisions, the long list of decisions that you mentioned, but it's the people. And I think that perhaps even before I begin, I would agree with you and say that the main message I'd like to bring you is that the technology is very interesting, it's very exciting, and has a lot of capabilities. But it's really about creating a situation where people can collaborate much better with one another. If it doesn't achieve that, then we don't really achieve that much. So, for that reason, I've titled my talk, Building Information Modeling, a process rather than a technology, or at least as much a process as a technology. Right. Okay. So what I'd like to do is begin with, perhaps, by sharing with you what I think building modeling is. And then I'd like to show you fairly briefly across a map of the construction process from conceptual design through detailed design and then construction itself, the fact that building modeling continues right throughout all of them. And it's certainly not something that's simply restricted to design. I guess I could say building modeling is not Revit, or Revit is not all of building modeling. There's a great deal more. I'll talk about technology trends and especially about process trends, how we think that building modeling is influencing and impacting and changing the way that we build buildings. Perhaps some words about how companies adopt building modeling and some ideas that we've collected from Europe and from the United States, especially about how these technologies are being taken up. And then, after all, I will try to tie this into what you heard last year in the Project Management Day about lean construction, and so I hope to tie them together at the end. And what I will do is I will do this on the background of some examples of projects. So firstly, let's decide, or let's have a working definition of what building modeling is. The most important part of this slide is to make the point that when we say BIM, the M is not for model so much as it is for modeling, as an action, as a verb. So it's about what people do with the technology. And if we want to refer to an information model of a building, we would generally just call it the building model or the information model. And of course, the building model is a digital, machine-readable record of a building. Its performance, its planning, its construction, and later its operation and its maintenance. I need to remember the point there. Oh, thank you. Okay, so what I want to do here is lay out the process of construction from program through schematic design, through licensing, detailed design, coordination, contracting, detailing, and so on, and try to pick out along that whole process different aspects where building modeling has been used and is being used every day around the world. And to do that, what I will do is, for each one, I will try to show you some of the different software that's available, but especially to bring you examples from projects that we have included in the new edition of the handbook that we have written. There is a new edition available in April, and we have 6 very new case studies of buildings from around the world, or projects from around the world where people have used modeling. So you can see that there are tools for schematic design, for architectural modeling, for structural modeling, for construction planning, for all of these different aspects of the construction process. And each of them have different tools that have been designed by software companies to do exactly those specific things. But the theme that follows through from tool to tool through the process is that the information models can be handed from one to the other. At least that's what we would like to achieve. And so we go all the way through from schematic design right at the beginning, all the way down here to quality control and commissioning at the end. And so using this as our map, let's perhaps go from one to the other and see examples, as many as we can manage in our time, of their use. So if I begin with the very early, very schematic design, there are tools like the Profiler, even Google SketchUp, Rhino, Revit Architecture, and the various tools that help us to analyze buildings at the very early stage of schematic design for energy. In the area of schematic surveying and scanning, we have software like Civil 3D and CloudWorks. And let's have a look at how that works. So here we go with our first example. I'm going to stand this side so that I can click and look. What you're seeing here is a building from Portland, Oregon, in the northwest of the United States. And it's a unique building because it was an office building. It was built some 15 years ago. Over here you see it complete. But it was never occupied. It was built when the real estate market crashed. They couldn't rent out the space, and the building stood there for many, many years. And along came the Marriott hotel chain and said, we'd like to use, they bought the site, we'd like to build a hotel. And of course, the architects went ahead and said, great, we have a site, let's design a big new hotel, which they did. And then they thought, well, the owner said, I'd like this to be a LEED platinum building. It must be very ecologically sound. And so the first thing they said was, how do you get points for LEED? The first way you get points for LEED is by recycling building materials. So then they said, well, can we use the structure and not demolish it, but use it as it is? And so what you're seeing here is the whole process. In the end, they dismantled all the facades, fixed the structure, redid all the interiors and all the facades, and built the new hotel over here. Now, how did they accomplish that? They took an office building and converted it entirely into a hotel in order to save the demolition. Well, they were only able to do this because they were able to use fairly sophisticated technology. And what they did was they began by doing laser scanning. You can see over here this process. Laser scanning of the building, brought it into building modeling software, were able to redesign the new parts, move those new, especially the facade pieces, to fabrication using, again, different modeling software, bring the pieces and make them fit. And why was this important? Because try to imagine a 15-year-old structure that's been designed for different loads, and it stood there and it's sagged and it no longer has straight form. Here, for example, is a laser scan of the building taken, and they took every floor from buildings across the road. And you can see that in the laser scan you can pick up all of the slabs. Now what they found was that the slabs had all settled, and so they all had different profiles. And so they used the laser scanning software to get the points, the point cloud, converted that into a survey, much as we might survey topography, and then were able in a surveying software to get the exact shapes of the slabs. And I will show you toward the end of the examples how they then used that information to fabricate very precisely the precast pieces to go on the front and make every piece different, but every piece fit perfectly in the building. So let's talk about the next phase, the architectural modeling, the structural modeling. And we have here a range of different software. The four on the top are generally associated with architectural design, and the other generally with structural design. You can see, for example, in terms of the variety of uptake, that in the architectural area, the number of websites and libraries of content has multiplied a great deal across cyberspace, I suppose. And so architectural designers have now a wealth of material available. When we move ahead into the the engineering analyses, you can see that here we have a very wide variety of different software. And almost all of these tools are able to accept models, do the analysis, and give their results. One of the nicest examples of this, I think, is this hospital project from the United States, from San Francisco, where you can see that the number of systems in modern buildings is very, very large. We have, yesterday at the university, we talked about the Empire State Building. The Empire State Building was built in 14 months, from nothing to handing over the keys to the owner. I think anyone who would contemplate nowadays building the Empire State Building would imagine that it would take years and years. Indeed, the Freedom Tower that they're building on the same site is due to take 11 years. So we ask ourselves, why do buildings now take so long when we were able to build them so quickly in the past? Well, part of the answer is exactly this, that they are so much more complex than they used to be. When we try to do to put all these various systems together, one of the advantages that building modeling brings us is the ability to find the clashes, the ability to coordinate properly. And I think perhaps it's these slides, although what you're seeing here are technical things. You're seeing systems, you're seeing building systems, mechanical systems, and so on, structural systems. But the message that I would like the slide to give you is this. There are different people responsible for each of those different systems. If the technology is able to create an image or a model where all those people can have a conversation and a discussion about it, and then they're able to resolve them and make them work together, then the technology is serving us. Otherwise, it's only nice pictures, of course. When we move from the building layout and the layout of the different systems to the analysis of the building, then of course we generally tend to think of this as structural analysis, energy analysis, acoustics, and all these other areas that you see here, lighting simulation, airflow, CFD. And these all exist, and they all work to some degree or another. Structural analysis is very well developed. Energy analyses are less well developed. But I think perhaps the important thing here is that a lot of these tools can now be used at very early phases of design. And I want to show you this example from Helsinki here. We have many from Finland here with us, and it's not very far away, but it is really a remarkable building, the Helsinki Music Hall. And it's remarkable for a number of reasons, but perhaps the main reason is that they were able to bring together a wide variety of tools, but especially at the very early phases of design, to try to achieve the things that Rode was talking about, to try to make the building as comfortable and useful for its end users as it could be. We can see here in the process that they used that they began in phase one with a basic architectural model, an analysis model for life cycle costing and for energy, cost estimating, and energy and airflow ventilation calculations. So all of these were done at very early phases and were able to influence the basic shape and design and configuration of the building itself. Only once that had been settled were they willing to go ahead to the next phases and do the structural modeling, the mechanical modeling that you see down here, and then combine them in order to make sure that the whole building fitted together, was coordinated correctly, and then move ahead into the construction phase itself, where it's being used for 4D modeling, viewed through 3D PDFs and so on, and being used to give feedback to the designers on problems, but also to manage construction on site. I guess the most important feature of this slide, and the pictures I'll show you right now, are that there are a variety of software being used, but they're all being linked. The links are not trivial. They're not simple, and they cannot be taken for granted, but they do work well enough that we're beginning to see comprehensive use. For example, you can see here how the building could be analyzed for energy. These are the temperatures. And of course, in attempting to reach the right design and yet keep the cost as low as possible, both for installation and for maintenance, the idea was to try to reduce the size of systems or to compare different systems. So you can see that you can run an analysis and then you can rerun it and see the effect of the changed systems on the temperatures that would be common within the building. Or, for example, the airflow. Somebody made a proposal about how to change the mechanical systems, and they wanted to ensure that that would not reduce the amount of air for the people in the building. And you can see that, having run the analyses, they were able to show that the effect would be tolerable. A fairly new area that is still very, very challenging from the technology point of view, but is becoming a little more available, is this idea that you can use models and check them for conformance to different standards. Whether they meet standards of handicap access, whether they meet standards of fire safety, and so on. And so we have here again a number of different software for conformance checking and for design review. And again, with this slide, I want to make the same point about collaboration, about cooperation between people. What you're seeing here is both a structural model and an architectural model brought together in a single software. And the idea is to say, okay, where are our coordination problems? Where have we made changes to the design that are not matched from one model to the other? And indeed, building modeling software really does help us with this, because it can identify these discrepancies very quickly, and it's very visual, so that when we have meetings, we're able to sit around the model, have the discussion, resolve the things, make joint decisions, and then go back and fix the models to reflect what our intent as people really is. And then, of course, in terms of costing, we want all these great things from our new buildings, but we want to be able to invest in them resources and efforts that are not limitless, but limited. And so we do need to do cost estimates and quantities. So we have quite a wide variety of software over here. Many of them key into databases of costs that are available in the industry in different places. So if you think of all these different software, here is an example of the first part, where we take the quantities. I guess most of you who have used models, building models, will know that you can pretty much click on the different objects, that the objects know what they are able to measure their own quantities, and so fairly quickly you can identify like objects, you can pull them in, associate them with line items, and get the costs, and get the quantities. And once you have the quantities, you can go ahead and link them from the model and the cost assemblies, the different line items in a bill of quantities, and get the costs. And then you can do visual estimating. You can begin to ask questions. If I change the material here, what's the impact on the cost? If I change the size of the store, what will happen to the thing? And when you make those changes in a model, you're able to see the changes to the bottom line pretty much immediately. And this is a very important tool, especially when we talk about changes in the nature of the construction industry. In most countries, traditionally, we're very used to the idea of design, then bid, and then build, where we design something, we finish all the design, we prepare all the drawings, we hand it over to the contractors to give a quote, then they do that, and then they carry on. Well, building modeling creates conversations between people that challenge that idea. We know that, I guess many of you are skilled and experienced project managers, and you'll know that the price on the tender is not the final cost of the building, and that in between, general contractors are very skilled at making claims for changes. And they're skilled at making claims for changes because there are often errors in the design, things left out of the design, things that don't match in the design. And contractors, if they're good, they're able to identify those and say, oh, that's where I will make my money, not on the bid. With building modeling, we get rid of a lot of that. The design becomes much more coordinated, much fewer errors. It's much harder to leave things out. And that is in many places having the effect of forcing contractors and engineers and designers, architects, to work differently. And so it's shaking up the way that people work in that sense. When we moved on to construction planning and construction detailing, the shop drawings and the preparation for going out to site, then here again we have a range of different software. used both on the design side and on the construction side. So probably many of you have seen or used tools like Tekla structures or like Revit structures and others to do this kind of model. But of course we can do very detailed design model, fabrication models also for mechanical systems. And as I said before, the buildings are very, very complex. This again is a hospital. So if we even just narrow in on one area of this model, then you begin to see the multitude of systems that there are and that need to be coordinated properly. Software that can identify those clashes at a very detailed level, this is now the fabrication level, are very common, and these are the things that, if used correctly, make it help us to catch those problems early and not wait until the construction itself to be caught. And because of them, there are fewer areas for contractors to make claims about changes during construction. And these are the things that, in a subtle way, are starting to change the way we relate to our construction. And here again, I put this slide very specifically because I didn't want to dwell just on the models and on the software that can compare the clashes, but I wanted to put the emphasis here on the people. And these were photographs that were taken during this project, and I think they emphasize a very important point. That is that on the construction site, or on the offices near the construction site, representatives of all the different subcontractors are meeting together. They're looking at the models. They're having these discussions around the models instead of, in the past, having the discussions around the paper drawings. And I think it's fairly obvious to us all that we have to be highly professional to read paper drawings well. Not only to read one set of drawings, but we have to read 6 or 7 sets of drawings simultaneously, compile all of that in our minds, and understand what's going on. Well, even most of our kids can read those models and understand what's going on. So the level of competence for people, the comfort of the discussion becomes quite different. And here too, you can see that in a very specific way, they're working not only on the design in 3D, but, well, it's a fixed picture, it's not moving, but they're working on it in 4D as well. So they're not just coordinating the product that will be built, they're talking about the process in which it will be built. Again, when we talk about construction planning, we can even go back, and this is also an example from a bridge project, which you'll be seeing a bit more of later. But what's the point here? Is that we're able now to bring models to the construction site and use them, for example, in this case, a laser scan and a photograph merged of formwork. And the idea is to use the laser scanning, bring it back into the model, and check whether the formwork is in the right place before we start pouring concrete. So again, we find that the models are stretching from conceptual design at the very beginning all the way through into the site itself. Here is what I promised you before. This is the same hotel in Portland, Oregon. And what you can see here, if we look carefully at this image up here, this white part here is the end of one of the slabs, the end of one of these edges. And if you notice here, you can see that there's an angle. The slab itself is not straight. It's over time, it's curved. And of course, they've curved and drooped. It was not built very well. But within the building modeling, they were able to put each of these pieces into the model very accurately, including the differences in height, fabricate them in a factory, bring them to the site, attach them to the building, as you can see here. Every piece is different. Although they look the same, the bottoms were all adjusted, and they all fit. And you're able to do this, and do it in a reasonable time at a reasonable cost, only by virtue of the technology. It's a very simple building in the end, but it would not have been able to be done in this way without those variety of tools, the scanning, the surveying, the modeling, and the control of the fabrication. When we think about this automated process, then another feature of it is that in the past, we had a number of sets of drawings. We had schematic drawings in 1 to 100. We had design drawings in 1 to 50. We had perhaps detailed drawings in 1 to 20. And as the life cycle of the project went, the information changed. Nowadays, we still have different models, But we don't start from scratch each time. We take the model we had before, we bring it into some new software, and we continue from where we left. So we don't have a loss of information at each step. And so its fidelity is much better. The point of this slide is not only to say that you can go from the models to the machines to the ducting, bring it to the site, and install it without going through the drawings. The important part of it is to say that the same model that was used for the licensing, for the permitting of the building, we use afterwards to do the quantities and to do the installation. We can do very detailed models of fabrication. This again is from the Crusell Bridge project in Helsinki, and you'll be seeing a whole case study of this bridge later today. And so I only took one slide, but I think it's a slide that emphasizes for us the level of detail to which we're able to model, and the level of coordination that we're able to bring between mechanical parts, steel parts, reinforced concrete parts, and all the other bits and pieces that go into the model. And this project really, I think, is remarkable in that the same model during construction was made available from the designers to the construction company to the fabricators of all different kinds, and maintained synchronized throughout that process. Of course, the impact on the construction itself is very deep, and you'll hear more about that. When we moved on really to we're talking about construction on the site, and we're talking about the 4D CAD, we can also talk about safety management, production control, and things like that. Here is a slide from a research project that we had 3 or 4 years ago, where what we're trying to do here is to say, can we use the models to help us make the process of building the building safer? Can we identify where the risks are? And what was done here was to say we have the construction model, we have a database of the loss of control events that can occur in a construction site, and we can link them by knowing the schedule of construction, and we can then calculate in advance, a few days in advance at each time, where different teams will be doing different activities. If we know the locations of those teams, and we know the typical loss of control events, for example, I could drop my hammer, but if I'm on the 4th floor on the edge, it could fall down 4 floors down, and if someone's working down there, it might be a threat for them. So if we can coordinate those things and run an assessment, we can actually measure the risk level for every team at every time through the next few days. And so that's what this does. I did have a quick movie, but I think we're going to not show it because it jammed the computer before. So that's what you're seeing here. The different colors represent the different levels of risk for teams as they work through the site. So let me talk about some of the trends, some of the things that are changing that we observe through the world. Well, automated code checking with the different software that can compare codes and check buildings whether they conform. This software does exist. It's still very limited. There is very little, perhaps I would say almost no, artificial intelligence in them. It's an area of development that could have gone quicker, but apparently the problems are hard enough that it's still difficult. So at some levels it works, and of course the most important level, the most significant one, is this idea of clash checking and coordination, which is very powerful and works very well. A thing that we observe is that the companies creating the software that most of you might use, Autodesk, Bentley, and others, one of the things that they're now beginning to do is to bring analysis tools inside of their authoring applications. So I can not only build the model of the building in Revit or something, I can also analyze it in a number of different ways. And that's a very significant change because it means that I can, in very early phases, do quick analyses of different options and better compare different alternatives. Yeah. This thing of parametric 3D catalogs, I show you a list of websites where you can find 3D catalogs. Certainly in the United States especially, companies that produce windows and doors and pipes and all sorts of building components very much have invested themselves now in providing 3D catalogs that you can drag and drop from their catalog directly into your model. So that barrier has almost entirely gone away. Doing that because they understand, especially as owners repeat building after building after building, they understand the impact on cost and on quality, and perhaps on safety, although that's mentioned less. There are new skills and roles. I think it's becoming quite clear to many, many companies that there is this role of, I call it PIO, Project Information Officer, that as buildings have become more complex, there's much more information about them. It requires more skill now to manage that information and to manage its transfer from phase to phase to phase through the project. And so it's very common now to see people specializing in these roles. I'm going to skip this item about increase in uptake. I'm not sure that the figures are that reliable, but it would appear that at least in the United States, where these surveys were done, that it's no longer early adopters. We're well over the curve and into the mass of certainly architectural companies who are using modeling. Here's an interesting thing, this idea of construction companies doing modeling. It's becoming much more accepted, and those companies that have adopted it in a serious way are doing it now in a very committed way. All these three that I listed here, Skanska, Turner, Mortensen, and others, they all have in-house BIM training. If you want to be a project manager for one of these companies, construction manager, you need to go and train and be thoroughly skilled in using the tools as part of your general training. And I guess we'll hear more about that later. And here's something that's interesting. Not many projects yet, tens, maybe hundreds of projects only, have been done using a new form of contracting called integrated project delivery. And integrated project delivery is all about commercial collaboration rather than commercial competition. And I'll be talking a lot more about this later this afternoon, and so I'll be very brief about it now, and we'll talk about it more. There are more and more countries and companies creating standards of how they should use BIM, how they should use modeling. There are the exchange standards like the IFC and the CIS and the National BIM Standard, but there are also individual organizations like GSA in the US or Senati Properties in Finland or Stadsbygg in Norway and others all over the world who now determine very carefully for their suppliers how they should work using BIM. Of course, green building, sustainable construction is much more, people are much more aware of what we need to do, and so the need for sophisticated tools early in the process becomes much stronger. 4D CAD tools become very common, we talked about that. And I think another change that's happening certainly around the world is that we are now beginning to be able to do prefabrication with variety. If you think about construction, we know how to do industrialized construction, where we make a lot of buildings where everything is exactly the same. Hundreds and hundreds or thousands of components are all exactly the same. But we know that people don't want those buildings. I don't want my building, as Rode said, it's not only Estonians, everybody around the world, I think, wants my house to be better than the next guy, and certainly a little different, and it must be suited to my personality, of course. That means we have to have customized buildings, like we have customized cars. I wouldn't want exactly the same model and color as someone else. So we have to have customized products, but we want to use prefabrication. We want to use mass production. Computerization and modeling allows us to do that. Perhaps some words about adopting building information modeling. When a company, a design company, a construction company, architect, engineer, contractor want to go ahead and adopt, perhaps some important points that flow out of this. Building modeling is a new technology, as we all know. That means that it requires new training, it requires new skills, it requires configuration, it requires setting up of new libraries, and all of those should be seen as an investment. These are not things that can be done in extra hours in the evening or so on. We have to make conscious, concerted, and planned investments, just as though we would invest in a piece of equipment or in machinery or something else. A construction company might buy a tower crane. They should consider adopting BIM in much the same way. But perhaps more important and deeper and more difficult is the fact that building modeling is not only a new technology, it's a new process. And so we know that we have to change the way we do design reviews. we know that with modeling we can have different design disciplines working in parallel, and they should work in parallel. That means that we cannot go through all the structural design, send the drawings for review, wait till they come back, then do the mechanical and do things in series. We have an entirely different, perhaps the best word is concurrent, simultaneous kind of design process. And that means that we have to have new business practices and new contract terms, new ways of remunerating and paying for the work and rewarding that imply cooperation and standards for collaboration. So we really do need to prepare fairly detailed deployment plans before we go out and start buying the software. Some more specific points, I guess. Start training with one. System configuration includes the hardware and the server and the plotting. I'm not going to go through all of these. You'll have the slides available, and so that might be helpful to a company who's beginning. It's all, of course, in much more detail in the book. But I find this table always very illustrative and very interesting, and it's taken from an architectural company, architect's office, and it underlines the change in skills, the change in roles, and in people. What you see here is before BIM and after adopting BIM, and you have here the different grade levels of the people working in the architectural firm, from the partner or the principal, the most skilled architects, all the way down to this would be the person doing the drawings in a pre-BIM, doing the AutoCAD. And you can see that what they're doing here is they're saying, they measured over a few months, and they said, how is the distribution of hours changing once they're using modeling? And the important thing is you can see that the senior architects, the project architects, are working more on projects. They're investing more time in design, but they're investing a lot less time in producing drawings. From a professional's point of view, that should be a very good thing. We can spend more time considering more alternatives, considering different design options, and we don't have to invest all this money and time just in the mechanical, technical area of producing the documents. And so you could expect in many companies, yes, it does require people with higher skills, but you could also say the people with lower skills we need fewer of, and the people with greater skills will be able to invest perhaps the same or more amount of time in doing better, higher quality work. That's how it should work out. And here perhaps the most important things. Choose to start in projects where the owner and the other partners in a project are cooperative and willing to collaborate. Talk with the rest of the design team before you decide to make this your first pilot project in BIM. Because success or failure of the models is not just whether you can produce the drawings in shorter hours. That's only a small part of it. It's whether the collaboration of information happens. It's whether the discussions and the meetings take place. And they only take place if there's a broad commitment to using the modeling, to working the same way. Prepare explicit agreements. It's becoming very common in the US for sure, that within the contracts they already define the level of detail that the model will reach at different phases of the project. They define the different ways that the teams will come together to collaborate. And in some projects, they will even define in the contract that toward the latter phases, the team must be in the same office. They sit in the same space in order to really collaborate. Yeah, I guess I have 5 or 10 minutes to perhaps now tie things together and tell you a little bit about the link between building modeling and lean construction. And here, we undertook a very simple analysis I want to show you briefly, and then I want to show you what we're dealing with now in research, in building modeling and lean together. So when you think about this process again, design, detailing, construction, operate, and maintain, there are a number of areas where, by virtue of using modeling, we're able to make the process leaner. Less waste is perhaps the most important thing. And if we sit down, last year you heard Lauri Koskela. Lauri and I and two students, two researchers prepared a table, and I know the writing is small, but I put it here really so afterwards you have it in your hands when you have the slides to take home. there is a list of lean principles that we can set down and say, these are the things that we need to do to change, to reduce waste, to make projects lean. And we can do the same thing with building information modeling. We can say, what are the features of building modeling technology and process? And you can list them out: visualization and generation of forms and comparison and clash checking and all sorts of other things. And then what you can do is you can compare the one to the other in a table. And so in the table you have at the top, you have all these lean, here at the top, we have all of these lean principles. And down here on the side, we have the BIM functionality. And you can take off your glasses and just see a blurred version of this. The important message is the green bits, because the green bits are all taken from case studies and instances where we can identify behavior where, by using the modeling, we're becoming leaner. There are some instances, here the red ones, where by using modeling, we actually create waste and do things that are not so productive. So by understanding this a little, we can get a better idea. But for us in the research community, I think that the important thing is that we use that as a guide to understand how we can begin to use the modeling better and to design new software, new tools that can help us to make projects lean. And that's what this project that I will show you is all about. It has to do with, well, you heard last year, probably, I'm sure Larry used the word flow many, many times in his presentation. So you heard all about pull flow control in lean production management, and I'm talking with you about building modeling. And when we bring these together, we have this idea of CAN-BIM. And here's what it's about. It's all about enabling, on the construction site, in the final analysis, work teams, team leaders, and the work crews themselves in very complex buildings, shopping centers, very high-rise apartment buildings, very big office buildings, and so on, transport buildings, and so on, that are not just more and more and more of one of a kind, but very difficult and complex projects. What we want to do is enable them to get all the information they need about the building, about their work, and about the work that other people are doing around them on the back of a model. So you see the model and the use of a touch screen, a very big touch screen on a support that can be brought to the construction site. Yeah, can you run that video? So what I'm going to show you is a very brief, I think it's about 4-minute video that shows 3 stages where we use the software, where we imagine that this kind of software can be used. The first stage is in the general master planning, where we build a master plan for our construction. Okay, can you make it full screen? So the trade manager, and turn off the how teams work. Turn it off. So the trade manager for each team would sit and prepare their proposal for the weekly work plan for the next week. And they would have task symbols that tell them what the different bits of work are for different teams. And they drag them down into the week. And this is what this trade, this crew, want to do next week. That's their work plan. And then they come together. You get the live version. Then they come together and they coordinate the work between the different teams. And when they do that, they have one screen here on the side where you see a building model with all these icons of the activities, the tasks of different teams. And you also see here on the other screen that this would be all the trade managers sitting together in a meeting, looking at these 2 screens. And here, you can't see it in very high quality, but it shows you for each space in the building and for each contractor through the week what the different tasks are. And what they're trying to do is to say, well, what happens if 2 teams want to work in the same space? And then we could look at the model, and the model will show us the state of the building and the temporary equipment, like the scaffolding. And we would say, well, can these teams work together there, yes or no? And we have a discussion between all the managers of what the weekly work plan should be. And then we come to this touch screen like you saw in the photograph before, and in a moment it will show you the screen itself in a live way. So you see on the screen the building, and you see all these different symbols, which are the tasks that each trade is meant to do during the current week. So you can see here, for example, that if I were doing drywall or some other trade, I could come along, I could have a look and see where I'm working right now. These different symbols like go or stop or complete or no entry, they're telling me what's the status of that piece of work. So if there was doing walls in apartment number 25 and the architect changed the design, I will have now a no entry sign because the work's not ready. There's some change going on. If I'm beginning I work there, it would have to be changed or demolished. There might be symbols like in progress, so I know there's a team working there, maybe one of my teams. And I know, for example, how long it's meant to take. I look and I see where the other teams are working around me. I can click on any of these, and you'll see that in a moment. I can click on any of these icons and it will open up and give me all the information about that task. It will highlight for me, you see here, that I'm clicked now on one task. It will show me exactly the objects where I need to do this work. And of course, this is a research prototype where we're not software developers, but in eventual software, it would have very detailed display of what the work is that I need to do there. And again, if I open it up, it's telling me, are the materials there? Is the equipment ready? Is the information complete? And is everything ready? So I could see a range of different information about this work that I'm about to begin doing now. It could, for example, give me the safety information. How should I be doing this particular kind of work? It could bring me the drawings. It could tell me where the material is and whether it's on site. And what you're seeing now is exactly how a foreman would come along, would log in to the system and report what they're doing. So they would say, yeah, show me what's on the third floor of the building, what work I'm doing now. He would say, yeah, let me see what I need to do. Just show me the third floor. And here's a work that I'm doing now. I've completed that piece of work. So what I want to do is I want to tell the system that I'm finished. So I tell it that I'm complete. I had a problem with something, and I'm finished that piece of work. And the symbol now changes to the work's complete, and the system sends a message to the engineers to say, come and check. And now I say, now I'm going to go and do this piece of work with my crew. So I click there on the go. I ask it to show me what the work is, so I have a good understanding of what I'm about to do. And then I would say, go. And it would ask me, okay, are you willing to commit to do this piece of work and finish it within 2 days? And I would say, yes, thank you, and walk away. And so it's not only that we're delivering information to the workers on the site about the process, but that we're also collecting information about what's happening so that we can inform everyone else. Okay, so some quick conclusions to what we've talked about. Building information modeling technology has reached a level of maturity that allows you now to adopt it. It's the idea that you should wait and see if the software develops more, well, we've passed that. Building model processes are still evolving, and this is definitely true. And it will be true for every country whose construction industry begins adopting the technology, will be impacted by new ways of working, will need to find new contract forms, new contract terms that help make the collaboration easier. Of course, building modeling brings extensive economic benefits, but it requires upfront investment. There's no gain without a bit of pain to begin with. And before I thank you and ask for questions, I would like to just add, of course, that perhaps the main area of research nowadays and development is that of how do we now bring all this information really to bear on construction sites, even more than just the clash detection, but in order to help us control work and coordinate work better. We're seeing already right around the world that building modeling helps us to coordinate design very well. Now it's going to begin helping us, we hope, coordinate construction much, much better than we have been. So thank you very much.
Ja kuna esineja nõudis rahva käest küsimusi, siis olge head, kes alustab küsimisega võib küsida nii eesti keeles kui inglise keeles. Jah.
Küsin selle erineva info sisestamise kohta, et nii ka nagu seal viimases demopilmis oli näha, et tegelikult on päris tõsine hulk ju vaja sinna infot kõigepealt sisestada, mille järgi langetada otsuseid. Et ma arvan, et päris paljudel saalis istujatel, kes teevad igapäevatööd, nad saavad aru, et üks asi on ehitada ja protsessi juhtida, aga lisandub siis ka veel selline tõsine hulk sisestada infot ja õiget infot. Et ma arvan, et paljude jaoks on see tõsine hirm, et kuidas te seda kommenteerite?
I understood you perfectly. Yeah, so of course, as to have a system like that where you could help it to coordinate people in real time, if the information is not up to date and reliable, they will not use it, and it would not have any impact for sure. So the question is absolutely correct, and we're quite aware of it as researchers at least. And on the other hand, we have the benefit of being researchers to make assumptions about the future that in construction perhaps you have to wait a little bit and you can't make. So we look around and we say, okay, what are the information systems we need to have in order to get a model like that up to date and available? Well, we need information, for example, about materials. When are materials, where are they in the supply chain? Is the fabricator in the precast yard, have they made those pieces? Are they shipping them? When will they arrive? How mature is their delivery? That's just one of the examples. Well, we look around and we see, for example, in the United States, they built we did research on this before, and recently it's become commercially applied, that in precast concrete, building a very big stadium, they applied RFID tags onto every concrete piece, and then they simply followed them through the supply chain. And I know that's being done in Denmark and other places, and is becoming better understood. We know, for example, that there are cloud computing systems where suppliers will key in what they're doing, and they're required by contract to record the dates when a piece of concrete is cast, or so on. So it might be technological through some tags and readers. It might just be by the contract requiring them to key in information. Equipment on the site. There is software available now that will help you to coordinate the use of tower cranes and hoists on construction sites and make sure that each team is allocated the right time for the crane to know who can use it when. Those systems are used. It's a question now of tying in the database of that record into a more comprehensive database. People. Do we know if people are on site or not on site? Do we know if they're coming or not coming and so on? Well, there are again, tag systems where people come to the site, you tag in, the system knows you're there, it knows who is there and who is not there, so that can also feed in. And as you begin to look across the whole spectrum, and I haven't shown it, of course, but we have a careful system architecture where you see each of the different pieces of information. They're not all available yet, but over time they will become more and more available. Now, if the system can save hours for people, instead of when I finish some, or if I'm doing some work and I'm trying to install some pipes, and all of a sudden I see I can't do it because there's a beam in the way, or there's a wall, or something's not right, then nowadays I would have to stop, I would have to think about this, I would have to call up the architect or call the engineer, they would have to come and see, we'd have to have a long discussion. Maybe in the meantime, my team is waiting or doing work that's not right. If we can save some of that time by filtering work ahead of time, then we have a big cost impact. And if we have a big cost impact of saving or removing waste, then it's worth our while to invest a little in collecting that information and making sure it's available. Now, a big part of it is knowing what the teams are doing. If the system is telling me the wrong things about where different teams are, then it's not useful. So, but one of the ways we can collect that information is by using the system itself. So we require that workers, when they want to begin a piece of work, that they tell us, yes, this work I'm going to do now. Then all the system knows. So we're actually not only giving them information, but collecting it at the same time. So the question is absolutely right, and it will probably take a number of years before commercial systems like this would become available where they tie this all together. Yeah.
Nii, nagu te näete, tänane külaline oskab lühikesele küsimusele hästi pikalt vastata, seega palun järgmine lühike konkreetne küsimus, aga küsimused selle rista sisse. Ma pean silmas mikrofoni, sellepärast, et seal üleval klaasi taga on inimesed, kes siis keeravad selle teise keelde. Nii et kes soovib mikrofoni?
Et nagu uute asjadega siin elus ikka, et nad tunduvad huvitavad ja põnevad, aga kui läheb katsetamiseks, siis keegi ei taha olla see esimene. Et küsiks seda, et kas on nagu praktikast olemas ka selline nagu soovitus, et milline võiks olla selline tüüpne projekt siis nagu oma iseloomult ja ajagraafikult, kus seda BIM-i on kõige parem katsetama hakata. Kas ta peab olema keeruline, lihtne, kiire ajagraafikuga, pikem, aga palju peab selleks eraldi ressurssi planeerima?
Well, I was hoping to be able to say yes or no, to give a short answer. But it's a good question. What kind of firm are you? An architect, an engineer, construction company? Probably you want to begin a project where you will get significant benefit. Obviously you want a project that's complex enough or difficult enough that you expect you will have problems in coordination. And I would imagine that for the first project you're going to try out, you would want to go for the benefits that are best understood. And I think that in terms of the technology, the best understood things and the ones that always work out are the clash detection. So I would choose a project that had fairly complex mechanical, electrical, ducting, structural systems. And then I would not so much sit down on my own, but I would sit with my suppliers, my subcontractors, the MEP and the plumbing and all that, and make sure that, and the structure, and make sure that they're all modeling and that we can bring it together. Because I think that if you're able to show your own management results fairly quickly, that encourages learning, and then you can expand to 4D CAD and to costing and a range of other things. But I would say that as a construction company, the clash detection would be the quickest way to see how you get different models, bring them together, and get quick benefit from them. Yeah.
So, happy. Okay. Järgmisi küsimusi meil on veel kuskil ilmselt vähemalt 5 minutit aega enne seda, kui kohvimasinad hakkavad mulksuma kõvasti. Nii et veel küsimusi. Tavaliselt antakse käega märku või siis pea nikutamisega, nii et kes nüüd, jah.
Ma küsiks võib-olla sellist provokatiivset küsimust. Kas te olete nii palju seda tarkvara proovinud ja seda tarkvara on veel ja veel palju. Kas on midagi, mida teie võiksite nagu soovitada projekteerijale, et mis on ühe või teise eelised ja mis suunast nagu oleks parem liikuda?
I'm not sure I understood what you really want.
I mean that you have so many tech lab, some Revit structure programs, right, and so on. But what are the advantages and disadvantages of every program?
All right. Yeah. Okay. Well, as you saw, there is a very wide variety of software available now, and they come in groups, I would say. There are the groups that are specifically for architecture, the groups that are specifically for structural engineering, and so on. I don't think that you can put your finger on it now and say this particular software is much better than any of the others. We live in a very competitive economy, free economy, and so when one company sees a new feature at another company, then it only takes a year or two before they all have the same, pretty much the same functionality. There are differences between the different software in terms of their ease of use and their learning curve. The reason that software like Revit and ArchiCAD and Bentley architecture and maybe Digital Project are used by different groups, it has to do more with their origins than with their makeup. Revit, for example, is very easy to use. We teach it in the university, and we chose to use it for teaching modeling because the interface is quick to learn. You can learn quickly and so on, and it's very parametric, and it really is true Vim. However, when you get to more complex projects, then you begin to find it limited. On the other hand, software like Digital Project is much more powerful and can deal with much bigger buildings, but it's a lot more difficult to learn and to begin with. Perhaps one of the ways, or I would say perhaps that if we're talking about architectural firms, the most successful architectural firms using modeling, I think, are those who make all of the software available to their architects and allow them for different projects to choose the tools they will use. I think it's a bit like if you came to a carpenter and you said, you need to build this wall, we're using only hammers. And someone else is, oh, we're using a nail gun, and somebody else is using something else. It's a good idea to have people who are skilled in using the tools and then decide which brand of hammer they're going to use. So for smaller companies, you have to make a choice of one, perhaps. But for bigger companies, if you're able to, you should make more than one tool available and use them at different times for different projects. And the last thing I would say, perhaps, is that try to avoid making the decision on your own as a single company. When you're involved in projects, and you can change from project to project, but when you begin a new project with a new owner, have a discussion about who the other designers will be, who will be the general contractor, who will be the suppliers. Have a meeting, discuss what information you're going to exchange using modeling, and then choose the software. Choose the software that you can exchange information most easily. The bridge project that you saw was very successful because all of the 4 or 5 organizations used the same software, in that case, Tekla Structures. The project in the same city, the music hall, they used other software, a variety of different software, used IFC to exchange. That's more difficult, but it gives you much more scope. So the short answer is, don't choose only by your own company, look at it at a whole project level, and don't be afraid from time to time for different projects to use different software for the same thing.
Nii, aitäh. Ja tundub, et 3 küsimust ammendasid meie esimese niukese, mis ta siis on, veerandi või selles päevakavas. Seega, kui te päevakava vaatate, seal on Rafael tuleb veel esinema peale lõunal, järelikult ta on nõus kogu päeva teie küsimustele ka vastama. Kui te ei julge tema nööbist kinni võtta ja tema enda käest küsida, siis küll te leiate tüki paberit ja saate sinna paberi peale ka oma küsimuse kirja panna ja siia arvutite vahele poetada. Siis seda lihtsam on nendele küsimustele vastata ja nüüd ma saan aru, et on olemas niisugune asi nagu enda tahab juhiseid jagada need.
Organisatsioonilisi küsimusi. Nii nagu te aru saate, kõikidel rahvusvahelistel üritustel on tahes või tahtmata inimesed jaotatud eri kategooriatesse. Esimestes ridades istuvad meie külalised ehk very important person. Need külalised, kes on peitunud kusagile tagumistesse ridadesse, kes ei ole veel leidnud kontakti meie ainsa veetleva daamiga Maarjaga, leidke kontakt, et te saate lunastada tema käest niisuguse paberi, mis annab teile õiguse juua kohvi. Kommertskülalised, kes on endale ostnud väärika teenuse, ja kes on juba saanud endale kõik need vajalikud paberid. Ja ka külalised kohvide jaoks on kaetud 4. korrusele, kus te ka hommikul vist juba läbi astusite. Üliõpilased, kes on ju vaesed nagu kirikurotid, teile kahjuks ma pean ütlema, et nüüdne kohvipaus tuleb kuidagi seal keldrikorrusel läbi ajada, seal, kus te iga päev käite, eks. Ärge solvuge, palun, ajad on rasked. Nii, ja siis läheb asi kõik edasi. 4 oleme me jaganud selle päeva seetõttu, et möödunud kord te ise ütlesite, et selles saalis istuda mitmeid tundi järjest on võimatu. Nii et nüüd siis tervise võimlemine.
Ja kõige viimane, enne kui püsti tõusete, keegi pole veel tänanud Rafaeli, täname siis praegu Rafaeli selle ilusa esinemise eest.
Ja erilise tänu ma tahan nendele daamidele seal üleval, sest me lõppisime Rahvaliga kokku eile, et kui ta liiga kihutama hakkab, siis me hakkame teda pidurdama. Me ei olnud vaja pidurdada, te olete fantastilised naised. Tõlge oli super, aitäh! Seda ma katsun nüüd Jüriga sulle orgunnida. Ma saan.
All right. You want to use this one or you...